Hey everyone, it's Joe Scarr. Today we're going to take a look at how we did some 3D noise TextMap sampling and used ImplicitShape in order to create this interesting mesh. Now, I will be honest, so we actually just took a snapshot of TP, threw a relax on there in order to get those nice curved things in there. The actual raw mesh looks something like this, which I know looks a little bit different. And then, of course, we just take that and make an array and rotate using standard max tools. So nice and fast and works really well. So let's take a look at the logic real quick. Start off with a memory just to store some values that we're going to need later. This iterate XYZ cube, we're going to show you how we rebuild this a little bit better fashion. This one has a little bit of a drawback, but basically it does the same thing. It runs through 3D space, samples a texture map, looks at the value of that color, and uses only a certain threshold in order to create a particle. And we kind of stir up their position a little bit, and we use a density map. A bunch of this stuff is just kind of left over. Viewport color in order to visualize the particles at birth, do a p-search, figure out what's my density of the surrounding particles, and based on that density value we color them. But we use that density in order to punch out certain holes in this next rule where they look at their density, and if it's within a certain range, in this case if it's over 120, then they are going to die to create those nice big gaps. So let's go ahead and see if we can't recreate that just so you can see the process. We'll start off changing max a little bit here, create a TP. Can't promise this is going to turn out exactly the same, but we'll try. Let's make a standard kind of system top level, because if and when we save this into a black box, we want to organize this so that it is easy and self-contained, and you get kind of a one-to-one naming system going. So I think we called them volume, so we'll just call them volume, and there's only going to be one group for now. Let's get this over here. Alright, so what do we want to do? We're going to have multiple rules, we know. We'll just call this birth XYZ. You can choose to design this, however you want. Really, you just need to do something that samples in 3D space. It could be as simple as filling a node full of particles using the volume pose, and then just testing that way. I kind of like a little bit more control so that you can have full control. So we're going to call this dimensions. Dimensions is going to be our XYZ, and when we make this, what we really want is to have this box shape that we're going to make to be centered around the position. So we're going to need to know, what's our total dimension, our total length, and we're going to take half of that to go one way and the other half to go the other way so that it's offset from a center mark. Okay, so we know we're going to need a float. I'm going to call this half, multiply by, you guessed it, and let's leave that for now. We're also going to need some -1 values in order to multiply these in a negative fashion. So let's do -1. And one of the things we definitely need is we only want this to happen at this first frame of the sim, at least for this particular case. So we're going to use a Boolean connected to an egg timer, which is the easy way to do this. And easy is nice. Let's have it only fire once, so we set that to single. For 0 frames, you don't need a number of frames, it'll still process. And what will happen is we're just going to use the reached value coming out of there. Okay, so what we're going to do is we're going to take this half value and multiply it against each of these X, Y, and Z axes values. So I'm actually going to choose to do a multiply here. I'll just call this that. Take one there, one here, and of course there. There's other ways to do this. You have to make some choices. I'm going to take this, we're going to get half that value on each axis. And before we get too much further, let's go ahead and create our iterators. So our iterators are going to, remember, an iterator lets you do multiple things in one sample, or even in per particle. So basically, like per call, it's going to let you run something multiple times. And in this case, we're going to have this be at the beginning of the sim, start this whole iteration process. Now we're going to go ahead and let's get the count out here. I'm going to set this up a little bit different than the first example I showed you, just so we can do it a little bit better. We're going to use a world raster. So let's just go ahead and remember to duplicate operators in TP. You hold down Shift and left click and drag. To remove operators, hold Alt and right click. Yeah. All right, so might as well get that division going there. So let's have our each of these axes divided by the world raster. For now, let's put the world raster at 1. And so that value is going to control our x-axis. We'll just call this iterator x. We're going to need one for, you guessed it, and for the other one. Okay, now here is something very important you need to know is we are going to be sampling on the x-axis, the y-axis, and the z-axis. We're going to sample 3 times, all in one little time step. The on has to control what is happening. So in this case, the x-axis, as it goes through whatever number of count it has, for each one, it's going to fire off a true to the y. The y, yeah, and we'll see how this process stacks up. Yeah, each one is going to do its count through there. Okay, so let's make a little bit more room. Let's get our, oops, let's get these here. My num, my z, and this, all of them divided by that. Okay. So now what I want to do is I want to start accumulating the position that's generated. This is our end goal here. We're going to want this XYZ to become coordinates in space, which we're going to feed into a TextMap. Oops, not TextMap. Remember, TextMap is a new one in TP 6.6, where you can actually do some very nice map handling adjustments, or just generate a simple little kind of noise texture field. In this case, we actually want the TextMap color, so let's dump that guy in. Okay, so let's go ahead and get through here. What we're going to do is we need to control our birthing on the left side and the right side of this each axis. In order to make that really easy, we are just going to use the lovely value to value. Now, iterators output, some different data. One of them, we could track how many numbers, like if this was 10 coming in, I think it would be 0, 1, 2, 3, up to 9. But we can just use normalize, because whatever the number is, it's just going to come out 0 to 1. We can use that 0 to 1 into a value to value in order to say, all right, if I come in at 0, I can be whatever number we plug into this output minimum. And then as that value, which of course from 0 to 1, it's going to go from 0 to 1, it's going to ramp up to whatever our max value is on the right side. Of course, you can move these up and down and move them all around and reshape this curve to kind of control your sampling, which is pretty fun too. So, but the out min and the out max are going to actually be controlled by these dimensions, the half size and the negative size. So the out min is going to be the negative half value of the x dimension. The max is going to be, of course, the half value of that dimension. So that's how we're going to connect these, and then of course we're going to set all this fun up for these other ones. We've got out min, out max, and of course we have three separate things like this, because that way we can have independent axis control. Let's actually go ahead and plug, I mean, you could just make it to always make a cube, but that's kind of boring. We're going to want something a little more fun than that. So let's say 20 by 30 by 10. Okay, so let's finish hooking these up. we're going to have our negative z value as the min, positive half z value as the max. These values coming in through here are going to be coming into the number normalize. Okay, now we're going to want to collect that data. So the x-axis we're going to collect here, y here, z here. Easy peasy. Okay, so now we need to add our map. Let's go ahead and just grab a cellular, not checker, that'd be a little boring. Okay, make that size, yeah, that's fine. So you can see here it ends up being mostly kind of white, a little bit of black, negative space. That's all fine. Let's drag, drop this in. Remember, make it an instance. If you make it a copy and you go back and you adjust it here in the material editor, it will not have an effect because it's a separate copy. You want them to be instances. There have actually been projects. Anyway, long story. I'm not about boring you with long stories. Let's get to the meat of this. Okay, so it's an instance. And we're going to take whatever those coordinates are now, and we're not going to feed them into the UVW. You can do that and see what happens, but you'll be happier if you put it into the surface position, which should also can mean world position. So we're also going to need to take whatever color it finds. We're going to analyze the value portion of that. And now here's something critical, right? So we're doing an iterator. These iterators we have to control exactly when these things happen. So we're controlling these on. So this iterator controls this one. All of that has to be combined, and when we test this color, it has to be an and here to connect these two. Otherwise it will not work. So let's go ahead and make our position born. We're going to do a pistol shot per call. So every time I get an on coming in, I'm going to create a particle at that position. Lifespan, sure. No speed, please. Variation, 180 degrees, because we're also going to play with the emission distance here in a second. Okay, oops, and I forgot to put them into volume. So, this is about right. Let's see what we get. Big thing, if you do this at home, set your simulation start to be 1 frame after the first frame, so you get a little bit of a kind of a safety zone. Okay, what do we get? We get nothing. That's great. So let's see what happened. Okay, that on. Yeah, is the bool on? Ha! Well, the bool's not on, so that would make it a little hard for this to ever fire true. And still nothing. Very impressive. Okay, let's check these. Okay, so what happened? Well, this is where we're going to start to use Debug Log window. Excellent tool. Learn how to use it because that's the best way to find out what is going on in your system. So let's just go ahead and do this. Make sure that's on there. Let's check this. Just pick a couple values. Alright, so we get a whole bunch of this going on. It's great. Maybe our threshold's not cool. It's not cool because what it's saying is whatever this color value is coming in, it has to be over 1 or under 0. Let's make that inside and 2.5. Turn off debug. Maybe we'll get lucky. Hey, look at that. Alright, so we get some interesting stuff there. That's cool. Let's make this a little more fun and turn edit on the fly off. Go here. My poor material editor keypad is broken. And let's look at our map. And our map, if we now start changing this, we'll get some cool stuff in there. Okay, so let's go ahead and jump to the fun. We're going to make a rule called shape. And I like to back up for this so it's not processing right away. This is under implicit shape, and let's take a look at some values. Let's use a surface. Yeah, we'll just turn this on and see what happens. Let's make sure master dynamic is showing the mesh. Hey, we got some mesh. All right. So it's probably our scale is a little off. Let's go ahead and increase this. And voila. All right. You can see we got a little isolated guy here. We can make a rule to kill that off if you need. Okay, so interesting little 3D map shape. That's cool. What happens if we, just out of curiosity, switch to chips? All right, get kind of a different look. How about fractal? Kind of blobby. Well, maybe we turn off fractal. We get that a little more. Okay. So now let's go ahead and change our dimensions. And our dimensions, let's make it a little bit taller. So let's go 30. Great, we got that. Okay, so our mesh resolution is fairly rough. We don't have a whole lot of particles right now, just 3500, so it's nice and fast. We can use some of the nice, I'm going to set mesh smoothing all the way to 1. Use these iterations here to kind of smooth out that mesh. So that's one step. Now what we can do is we can, I should have organized, well, there's just TP there. Let's make a layer for that. Let's also make another layer called results. Let's select TP. Results is the currently highlighted layer. Let's go tools, snapshot, bang, hide TP. Okay, so we still have this. Now it's just plain old max object, and we can throw whatever fun modifiers you want on it. For now, let's throw a relax and crank it way up, and so you can get some nice curvature on there and make it look really smooth. You could throw, optimize or whatever as well. So there's that. Now, just by tweaking the map settings, changing the dimensions, throwing combinations of maps in here, and then playing with the modifiers after you do a snapshot, you can get some really cool results. So this is basically how you sample a 3D noise texture. Just run through it one more time. We've got the bool into an egg timer in order to act as a one-time switch, so only fire at the beginning of the sim in this particular case. Set up a world raster so we can control the granularity of the number of samples. We use the dimensions to define the overall bounding box. We use the half multiplied by each axis by -1 in order to get the make it centered, so it's got a negative component, positive component, and centered around this axis here. And then we, for each of the iterators, remember we're controlling each one of them on, and using that rasterized dimension for the count, and then using the number normalize. So whatever that count is going to come out as 0 to 1, which we can then easily interpret between 0 to 1 and control our out minimum and out maximum being the negative axis, half of the negative axis value and half of the positive axis value, in order to control the where in this particular axis it is. And then just doing that multiple times, one for each axis, combine all those to create a position, take that into the surface position portion of the texture map color, and throw in whatever map you want there or combination of maps. You can be very creative. Get whatever that color is coming out, so we can test individual components of color, like in this case the value, in which case we're just going to say anything from 0 to 0.5. And of course all of this you can customize to your heart's content if all those conditions are true, meaning if we are inside a multi-layered iteration and that particular position that was generated meets that color value threshold requirement, then go ahead and create a particle there. Nice thing about this method is that it tests the position before it creates the particle, versus creating all the particles and then filtering them afterward, which, is not bad. It's just this is a little more closer to the immediate result and saves you an extra step. Of course, you can add another step like I did in the other file, where we do actually look at the densities of those and kill off certain parts, or you can kill off certain parts at random or whatever other criteria that you like. Now, Okay, and then of course we feed that into an implicit shape, and you're done. Take a snapshot, play with it at max. Of course, if you're going to make this animated and you need that kind of access, you'd probably end up using groups as objects, and that way it would create a volume object on some layer that you could apply modifiers to, so that this could update over an animation. All right, that's it. I'm going to go ahead and save this file out for you guys. Hope you're doing well. Have a great 2018, and keep an eye out for more awesome features coming out in TP. Cheers.